Hello, I'm Stefan Graeber. I'm the project leader for LXD. And in this video, we're going to be wrapping up this little series of videos around authentication with LXD by looking at arguably the most common authentication mechanism, which is simple TLS client certificates. I waited to do this video last because I wanted LXD 423 to release, which has quite a few nice improvements in the flow for authentication when looking at TLS certificates. Basically, the way it works is LXD runs an HTTPS endpoint. When it's configured to listen to the network, clients can talk to it. The way we authenticate clients is by using a client certificate. So the LXD CLI or some other tools will generate a key pair and then use that as a client certificate when connecting to LXD. And if that certificate is in the LXD trust store, then you've got access to LXD itself. On top of that, you should be doing validation of the server certificate itself, either by showing the fingerprint or having the user provide the expected certificate effectively. So that's pretty much the basics. The way in the past, at least, that you would have a client add itself to the trust store, there were two options. One was to set a trust password on the server side. So that would be a password string that anyone who knows that can add themselves to the trust store. And that's probably the most common workflow where you do LXC remote add, and then it asks it prompts for the fingerprint. If you say that's good and it asks for the password, then you're trusted. That's got some obvious issues. The fact that it's a password, so it can be brute forced. Also, not everyone realizes that the password is literally just used for that initial trust, so you can actually unset it at any point, and that has no effect to existing trusted clients. It only prevents new ones from adding themselves. So if you're using a trust password, you really should be unsetting it after adding your clients because there's no reason for it to remain set. But in general, that's how that all worked with LXD. It was like as close to an SSH type workflow as we could make it. But we've recently improved things quite a bit. So specifically, a few releases ago, we added support for cluster join tokens. And the way that would work is that you would run LXC cluster add, give it a name, and it would give you a pretty long string of characters, effectively a base 64 string, that you could give to the joining cluster member. And that in one string gave everything it needed. It gave it the IP addresses that the server can be reached on. Even if there are multiple addresses, they're all listed in there and the client can try one by one. It gives the expected fingerprint for the certificate of the remote server, so it takes care of that part of the authentication process. And it gives a unique secret that can be used exactly once to add a entry in the trust store on the remote server. So we rolled that out for clusters, and that's really the way we are setting up all clusters these days because that's so much better, that's more user friendly, but it's also safer. And now with LXD 423, we added support for the same thing, but for normal remote add operations. So this video is going to focus on using that new workflow. We're going to be effectively ignoring the old one using the trust password and just look at what can be done once you have that, and especially around the kind of restrictions that can be applied to TLS certificates. That's not going to get you the full, feature set and granularity of using the RBAC service, but you can get some of those benefits without having to run a third-party service and all of the integration that's needed for that. So let's go and look at that. Right here, I've got a Raspberry Pi with Ubuntu 20.04 installed. LXD that comes with it would be 4.08, I suspect. Yeah. So we're going to be refreshing that to a more recent version of LXD by switching to latest. So it's going to be pulling LXD 423, which then gets us support for the join tokens, or the remote add tokens, effectively. Once that's done, I'm just going to be setting it up. No cluster, no nothing complex this time. I'm just going to be doing it standalone on a single server. So running LXD init to just configure storage and networking. And then we can launch an instance to make sure it all works, and then try to reconnect remotely to it. So no clustering, local storage using CFS here, and then no connection to MAS, local bridge, effectively just hitting enter at every single question. Actually, there's one I should probably have answered yes to, which is the would you like LXD to be available on the network? I should have done that, but instead you can do it manually after the fact, so might as well show that, which is setting the HTTPS address to :8443, and that means it's going to listen on port 8443 on all addresses that it has. Now let's just launch a basic container. So just downloading, unpacking, and creating that instance real quick. And after that, I'm going to be able to play with adding that Raspberry Pi as a remote on my local system. Okay, so to do that, I'm going to start a local shell. And do LXC remote add. Let's call it rpi. And this one has a DNS name, so it's convenient. So the old ways I would do this effectively. And this would be asking for the fingerprint. So then this need to say yes, and then you have to enter a password. I don't have a password, so this would not actually work. But let's go and do it the current way instead, and do config trust add. So just saying that I want to add someone. Let's call the client Dakara. That's the name of my machine, and it gets me this token. And now on my client, what I can do is remote add rpi and put the token, copy pasting it in. Hit enter, and that's it. I can remote switch over to rpi now, and I can talk to LXD. Say you were to create another token, you can do trust list tokens, I believe. Yeah, which then shows you, let me just zoom that back a bit, gives you a table that shows the token and the name for that token. And you can revoke the token based on the name, at which point tokens have been revoked. No token are valid at this point. And if we look at what's currently trusted, the only thing that's trusted is my client right here. So that's really the basics. That works great. You can do trust add as an administrator on the server, get that token, send the token to a user on your network, and they'll be able to just consume that and connect immediately. No need to exchange anything else. Everything is included in there. It's all good. It's worth noting that those tokens only last until LXD restarts. So if LXD gets updated or restarts, you restart the machine, all pending tokens get invalidated and you've got to create them again. Now, that's really the basics. That works all fine. That token effectively gets me full admin access. I can do absolutely anything I want. I could create, say, a new storage pool called foo. This works fine. I can create privileged containers. I can do whatever I want. But what if we created some projects for different users? So let's create a project called foo. On my client, I can see that my user is trusted to say both default and foo and currently has full access. One thing you can do not to restrict it is you can look again at the trust list and then edit the particular fingerprint, the particular certificate inside of that trust store. And in there you can do, okay, the client is to be restricted and the only project that they have access to is foo. You save, and then the client can only see foo, so they can switch to foo. But say they wanted to create a storage pool, ain't gonna work anymore. Now, that effectively restricts them to just that one project, and that gives them the equivalent to a operator role in RBAC. So they're allowed to create, delete, whatever they want, that so long as it belongs to that project. They are not allowed to modify their own project, and they're not able to do anything that would globally impact LXD. Now, you can also do that directly when issuing a token, because right now it's a bit unsafe. Like in this case, I gave myself a token that gives me full admin access, and then I went and restricted it. But during that period of time, I could have done whatever to take over the system. So let's just do this again. I'm gonna switch back to my local remote. I'm gonna remove the RPi remote. And now on the server, I'm gonna also remove the trust store entry. So effectively reverting everything. So if we look at the trust store now, nothing is trusted. And let's issue a new token. But this time I'm gonna pass the name directly on the CLI. I'm also gonna do restricted, and I'm gonna do projects foo. And that gets me a token, which I can consume the exact same way. And then I can switch to that remote. And let's look at the project list. Well, this time I only have the foo project, just to make sure I'm still not allowed to do anything that will have a global impact. So that's really perfect for any kind of shared environment. You can create projects for different users. You can even create shared projects and then give multiple user access to the same project. That's a comma-separated list of projects that the user has access to, and users will be restricted to that particular project. They can create stuff, they can delete stuff, but only as long as it is actually in that project. Now, let's just effectively initialize that project, because an empty project doesn't come with anything useful in the default profile. Whoops. So I'm just gonna be adding profile device, and I'm adding a root device. So it's a disk. The pool is default, the path is slash. So that gets me, the name of the profile there. So that gets me a root device. Then I'm adding myself a network card as well onto the LXD BR0 network, and interface is if0 inside the instance. Okay, so with that, I can now create an instance, and that should just work. Just give it a few seconds to start up. Okay, so all right, everything worked as expected. Now, if I create a second instance, and this one I say I want it to be privileged, this still works. And that can be a bit of an issue, because privileged containers would let you easily bypass confinement and security, and effectively that user, even though they're restricted to a single project, can still do very, very bad things. Let's do a bad thing. So I'm gonna be adding, let's call it ITSI, and it's a disk which maps /ITSI on the host to /man/ITSI inside of the instance. And now if I go inside U2 and I go look at mount ITSI, I see the hosts /ITSI, and now there's absolutely nothing that would prevent me from going in there and modifying the password file or modifying the shadow file, and effectively create myself a user, and then, why not go and modify sudo as.d and give myself full sudo access on the host system. There's nothing that prevents me from doing that, which is why we probably don't want to allow that to random users. To do that, you can go and edit the project. So I'm doing that, and in this case on the server, but because you need full admin privileges to do that. So project edit foo, and we're gonna make the project restricted. So by just doing that, all the restrictions will be in place, which means no more privileged containers, no more nesting, no more any kind of device that's risky, so no more disk pass-through or any of that kind of stuff. So if I do that, and now I try to launch another privileged container, this just fails, saying security privileged is not allowed. And there are a lot of options there that you can use to control project restrictions. We can go and look at the documentation for that real quick. So if I go into configuration and projects, there are some of the options down here around restrictions. So you can choose to allow, by default, everything is blocked. Then you can choose to allow backups, choose to allow cluster groups, cluster targeting. You can choose to allow low-level configuration. That's a bad idea because if you allow this one, pretty much the same as not restricting the project, but you can still use that. You can allow nesting, can allow privileged containers, can allow any kind of different devices. Some of those are more risky than others. Passing through a GPU is not too problematic. Passing through a USB device might be okay. Passing through a Unix block, char, or hot block device, that's probably a bad idea. But it really depends on what you want a given project to be used and who it's used by and how much do you trust them and with what. Those options can be changed live by an administrator on the project. As I said, me as the user. So if I go back to the terminal here, so me as the restricted user here, if I go and I can list the projects, I see foo, I can go and do edit foo, and if I go here and I try to, disable the restriction, it will not allow it. I get not authorized because I'm not allowed to modify my own project, thankfully. So that's a pretty strong restriction that's in place, and that does let you create restricted projects, hand out tokens to whoever you want, who can then add your system to the LXD client and then connect and interact with that project with whatever restrictions you've put in place. In this particular case, to just kind of wrap things up, we showed restrictions, but you can also put limits. So you can decide that a given project can only have a fixed number of containers, fixed number of CPUs being used, allocated disk space, total number of instances, so that's containers plus virtual machines. So for example, you could, if you don't want someone to use virtual machines, you can totally put a limits.virtual machines of 0, whereas you've got like a limits instances of 10 or something like that. Memory can be restricted, number of total processes can be restricted. That's particularly useful to avoid the user running a fork bomb and running the entire system out of resource, for example. So all of those options are available there, and you don't need to run a cluster, you don't need to run RBAC and all of those services to get the benefit of that. You can run it on a single standalone LXD or a small cluster if you'd like, and use those tokens and hand them out to the users you want. And if you want to change what they can access later on, you can totally change that live. Maybe one last thing to show in that regard is just, again, my user is currently limited to foo, but I can, as the administrator, just lists, and I can go edit the certificate and just change here that I want them to have access to both default and foo. And oops, a bit of a syntax error here. Oopsie. Did that work? There must be a bit of an issue here. So this is supposed to work, but you can modify the list of projects that they have access to, and it can be anything that you want. Actually, let me just try it by doing it from the start. So if we remove the entry and we add one, and we do default and foo. This is obviously a bug that we're gonna be sorting probably by the time you even see this video. RPi, this, okay. Remote switch to RPi and project list. Yeah, so there's a bug, I think, with the default project and the way it's handled. So we're gonna be fixing that for sure. But yeah, it is designed so that you can put a user in multiple projects, and you can have multiple users access the same project as well. So you can do shared projects for a team, for example, while also giving individual projects if you'd like to. And it's quite nice and flexible. It's not as flexible as running RBAC, but it is readily available and very simple to set up for everyone. So that was a overview of our normal TLS-based authentication and some of the newer features, especially around restricted projects, limits, and limiting specific certificates to specific things. Again, sorry for that end of the video, which ran into a tiny technical difficulty. That's going to be sorted out by the time you're seeing this. So you'll actually be able to restrict to multiple projects, and that will work properly. I hope this was useful to you, and yeah, that's the last video in this series on authentication. So if you don't care for LXD authentication, then be reassured we're going to be talking about something else in the next one. So thanks for watching. If you've got any questions, comment down below, go to the community forum, and I'll see you in the next one. Bye.